Hey there, welcome back to Farmcraft. In last week's video, you saw me tear my boom lift apart. I got the three boom sections. Here's the mid boom, there's the fly boom, the other boom is up on the machine. And you saw me taking out the hydraulic cylinder, all the chains, the sheaves, a whole lot going on there. But I'm willing to bet that most of you don't really understand how it works, because I've looked at this mechanism for hours actually, and it has taken me a long time to really be able to grasp what's going on here. It's a fascinating mechanism, and it's interesting to look at it from an engineer's perspective. You have one hydraulic cylinder and you need it to actuate two booms. You need one boom to move twice as fast as the other. And how do you accomplish that? The first thing I'm going to do in this video is we're going to build a model, and we're going to go through how this thing actually works so that we can actually understand it, because it's pretty darn cool. The second thing we're going to do is, at the end of last video, I started a fire on the lift in a horrible spot, and I got it out, but I definitely did some damage to the machine, so we're going to look at what we have to do to fix that. And then we can get on with this repair. So as usual, let's get to work. So this is from the service manual, and I can tell you, I can look at this picture for a long time and not really understand what's going on here. It's a cutaway, obviously, and you've got your three booms. Here's your base boom, here's your mid boom, here's your fly boom. And the base boom continues all the way to the back, and that is where the chain attaches, and that's where the eye of the cylinder attaches on the base boom. Here is the mid boom, which goes underneath there and then right there. And those are wear pads for rubbing against the inside of the base boom. So this is the mid boom. It's attached to the hydraulic cylinder as well on the barrel. So right here is those two little half pins that I took out. The thread might. So when the rod extends, it's going to push the base boom this way and the mid boom that way, and obviously the base is fixed, so the mid boom is going to extend, and when the cylinder retracts, vice versa. Now the fly boom, it's this third one here, goes all the way through to there, and right here, and here's its wear pads inside the mid boom, and come down through this cutaway here. This is the chain attach block. That is attached to the fly boom. This is the fly boom again, inside the mid boom. So it's very hard to, I mean, this is a very challenging picture to draw. Whoever did it did an awesome job, but it's tough. So what do our chains do? We have a chain attached to the base boom. It goes all the way through to a pulley on the end of the cylinder, and then it goes back and it goes to the chain attach block, which attaches to the fly boom. Then it continues over another wheel, and that wheel is on the mid boom, and then it goes underneath the mid boom and then attaches to the base boom. So the chain's attached to the base boom in two places, fixed length. So there you go, you understand how it works now, right? Yeah, I think you can see why I chose to build a model, because you can see how it's put together, but it's not exactly obvious how it works. I've got the three booms here. One side's cut out of each so that we can see what's going on. And I made them different colors to help make this a little easier to see. Let me throw it together and we'll see if it actually works. Here's my chain. And this represents my hydraulic cylinder. Okay, so the hydraulic cylinder, there's actually a rod here, and what it does, it pushes between the mid boom and the base boom. So it's attached to the mid boom, the end of the rod is attached to the base boom, and when it extends, it's pushing on the mid boom. So I'm representing that just by pushing here. This is exactly the setup that it is on the actual lift, as far as where the attachments and everything are, where the chains are. So when I push on the mid boom, you can see the fly boom extends. So I've just pushed the mid boom this far, but the fly boom extended this far. Or base boom to mid boom is this distance, mid boom to fly boom is the same distance. And then when I pull back, the reverse happens. How cool is that? Now I guess it depends on how good you are at visualizing things. I don't feel I'm the best at it. I looked at this for a long time trying to figure out why is that fly boom moving twice the distance of the mid boom. This is kind of fun to play with. I ought to put this in my, my merch store. Well, let's simplify this a little bit. I'm going to take the chains and the fly boom out. Alright, so now we have mid boom, base boom, and a cylinder. This attachment here was those two half pins that I took out, and this attachment here is the eye that had the Nemesis pin that I couldn't get out. This is simple. You know, when the cylinder extends, the mid boom extends, and when the cylinder retracts, the mid boom retracts. The chains have nothing to do with the mid boom. The chains are there just for the fly boom and nothing else. So now I'm going to put the chains back on, but I'm going to leave the fly boom off because I think it's going to make it easier to understand. So what we have now, same setup, mid boom and base boom, nothing has changed. But now we've put a chain that's attached to the base boom. Goes out here over a pulley. Comes back underneath. Goes over another pulley on the mid boom. Goes back underneath, so it's going back this way. And it attaches to the bottom of the base boom. Now on the actual machine it attaches right there. I just took it through and then attached it there just to make it easier, but it's a fixed point there. I put this larger screw here to make that more visible. You can take a look at that screw and see what it does. You see how fast it's moving? It's moving twice as fast as the mid boom is. So let's line up our marks. Here we've got a line here, here, and the screw are all at the same place. So if I come out to this point, I've moved that far, but the screw is all the way out here, double the length. So how is that screw, or maybe more accurately I should say, how is this piece of string moving twice as fast as the mid boom? Well, the reason it's doing that is because it's going over a pulley. This is a 2-to-1 pulley setup, and let me just go show you a simpler version, and I think you'll understand what's going on here. All right, what we have here is a 2-to-1 pulley setup. I've got a fixed point here. I'm coming to a heavy object here, just a piece of steel to represent, and a pulley. Rope goes through the pulley and then comes back to here. So we're all fairly used to this. If I want to pull that heavy weight towards me, say it's 10 feet away, I've got 10 feet of rope going to it and 10 feet of rope coming back. In order for me to pull that all the way to here, I'm going to have to pull 20 feet of rope. So I've got a 2-to-1 mechanical advantage. I'm going to put a little piece of flagging on the rope here so that you can keep track of it. Watch the metal plate and watch the flag. So the flag is now to me, the metal plate is only halfway to me. So this rope is moving twice as fast as that is. It just so happens that if I were to take a hydraulic cylinder and push on this, that rope is still going to move twice as fast, just in the opposite direction. So you're using a 2-to-1 pulley system, but rather than multiplying your mechanical advantage by 2, you're halving your mechanical advantage, but you're moving faster. So the cylinder has to work harder to move the fly boom, but the fly boom moves twice as fast as the mid boom, just with this simple pulley setup. So now I think you see, all you need to do is just attach the fly boom to the chain, and the fly boom is then going to move double the speed of the mid boom because of our 1/2 to 1 pulley system we have here. 1/2 mechanical advantage, but it moves twice as fast. So you can see now you basically have 2 mechanisms going on. You just have the simple hydraulic cylinder that's extending the mid boom, and then you have the 2-to-1 pulley system using chains that is extending the fly boom. Now, this is not an unusual mechanism. There's nothing special about my lift. This is used on all sorts of telescoping machinery, forklifts, boom lifts, boom trucks, and I'm sure many other things. This is just not something that I've ever seen before in detail, and I don't think it's very common for most people. So really interesting to me, but for people that have seen this before, they're probably yawning. They refer to 2 different chains in here. They refer to an extend chain, and they refer to this one as the retract chain. And it was confusing to me because it seems like it's all one chain, and it just attaches at this chain attach block, and that's attached to the fly boom. But it does make sense that one's the extend and one's the retract, and I'll show you why. If we disconnect the retract chain so that that's not doing anything anymore, and we go to extend, it will extend. But if we then try to retract, it will not. So that is, the tension on that side is necessary to pull it back in. And the opposite is also true. If we disconnect the extend chain, it will not extend, but it will retract. So it all depends on which side of the fly boom that you're on. For the sake of showing you all the situations, if you were extended, you were up in the air, and your extend chain broke, what would happen? Well, this and this are based on the cylinder, so the mid boom is not going to move. Would the fly boom fall? There's a little friction there, but the answer is yes. The fly boom would fall if the extend chain ever broke. And it would only fall down as far as the mid boom, because this cylinder is still in here. It would hit, and it's not going to be able to fall all the way through. The weight of this fly boom, with the basket and everything, is maybe around 1,200 pounds. I'm guessing a little bit on that, but the entire boom assembly with the cylinder is 4,500 pounds. So the basket and the fly boom are just not that heavy. These things are engineered so that one of the chains can easily run it. So one of the chains is plenty strong to do everything you need to do. The reason there's 2 chains is just to have a backup. So if one chain breaks, you're going to hear it. I mean, this chain's going to be in here flopping around when you're trying to move this thing. And it would be obvious that the chain is broken. You would still have a whole other chain to keep you safe. Now, what's the safety factor on these chains? I don't know exactly. These are put in with tension. There's a chain adjuster here. You tighten it down to 50 foot-pounds, and that puts the chain under tension. So it's got a constant tension. The fly boom is held by that chain. The thing is, each chain on mine, I checked the specs of my specific chain, has a braking strength of 23,000 pounds. So if this fly boom weighs, say, 1,200 and I put 1,000 pounds in it, that's 2,200 pounds. I mean, I'm not even straining that chain. The safety factor that's built into this thing is tremendous. This is like, we get in elevators all the time and we don't worry about it because the safety factors are tremendous. Well, this is built like an elevator. I don't have to worry about this thing breaking. Now that I've looked at all the mechanisms and I know the chains are in good shape, nothing's rusted out, I am 100% confident in this boom assembly. Isn't that cool? All right, now the part that I'm really looking forward to, sarcasm, is let's see what's going on with the fire damage. You can see I left the ignition on because it doesn't do anything. I've been leaving the battery disconnected until I get this figured out. Of course, I just reconnected it so that I can try to troubleshoot. And this is what I get when I try to start. Nothing. So we are gonna spend some time working on this. You know, I like working on things. I do not like working on my mistakes. It's one of those things I just end up kicking myself mentally over and over. And it just puts you in a bad mood because you feel like you're doing all this work that wasn't necessary if you just weren't such an idiot. I don't know if you guys are like that, but that's what this is going to be like for me. Whatever, let's get it done. See me shaking my head here? What do you think I'm thinking about? Yeah, I feel like a real idiot starting that fire, and now I've got to spend many hours fixing the damage. Getting this box out of the way gives me access to the harness that goes over to the engine. And here it is on the other side of the machine. Gee, I wonder why that's not working. Oh yeah, bare copper all through it. Isn't that nice? All right, let me get the electrical tape. I'll tape these up and we're good to go. Okay, maybe not. So this would be a great time to have some of those butt connectors that you just solder. You know, you crimp and then solder them and you're good to go. I don't have them. I could order them, then I'd have to wait. I don't want to wait. So what I'm going to do is just solder them with a good old soldering iron and heat shrink. Do one at a time and I can't get the wires mixed up. The good news is there's enough slack in these wires. There's way more than I need. So I'm going to lose like 18 inches of wire. That'll be fine. So I will shorten them all an equal amount, solder them up, heat shrink them, tape them, put a new loom on, and the wiring will be fixed. And then we'll go from there. This is flux, just helps the solder flow and stick. That'll do it. Might Might use a bigger piece of heat shrink next time. That heat shrink was kind of thin and I couldn't get it to slide all the way over the joint, so I'm using some electrical tape on this one. I'm going to use 2 layers of bigger heat shrink on the rest of them. One down. Slowly but slowly, we'll get it done. There's Big Mama. That one right there. And she's walking better today than I've seen her walk in a while. Still favoring that left back hoof. Well, I say hoof. It's not her hoof, it's her hip. That thinks, you know, she's an old cow. He thinks she's probably just got arthritis in her hip. Poor old lady. Coming to get some fresh grass. She's about as wide as she is tall. Come get it, Big Mama. Hey, 71. You photobombing? Even after repairing the engine wires, it's still, the ignition won't come on. So there's more damage to probably more wires under there. And I can't get to that area. The boom is down and I got to get the boom up. It'd be great if I could use the machine to raise the boom, but the ignition won't come on. So I can't use the aux pump either. I'm going to have a tough time with my tractor trying to get this boom up and get it up very far. All the hydraulics on this machine have holding valves. Now, usually those are directional. It would probably only hold it so that it can't come down. I don't think it would hold it against going up. Let's talk about holding valves for a second. On a normal cylinder, you pump fluid behind a piston to extend the cylinder. If this is my lift cylinder, this is lifting the boom. Now that's all well and good unless a hose breaks, which is a common thing in hydraulic systems. Then the fluid would come out at a rapid rate and the boom would drop. No bueno. And that's where a holding valve comes in. It's basically a fancy check valve. This valve has a spring that pushes this down and closes this port. But if high pressure fluid comes in here, it will be able to overcome the spring pressure and go ahead and extend the cylinder. Now once the cylinder is extended and the fluid wants to come back out, this valve is going to be pushed closed and the fluid is going to hold it closed. So it's not going to be able to get out. It's a check valve. So these are placed right on the cylinder and this is a hard line. In other words, a metal line directly connected to the barrel of the cylinder, there's no rubber hose in here that could catastrophically fail. And you can see in this setup, if this hose were to suddenly burst and all pressure was lost here, this valve is going to slam shut and the lift cylinder is not going to fall. The only way to get fluid to come out of this setup is if you pressurize this right here, pushing this piston up and pushing the check valve out of the way. And that is the pilot hose that does that. So this must be pressurized in order to allow fluid to flow here. And of course the machine only pressurizes this line if a down command has been given to the control valve. At all other times there's no pressure on this line and the boom is being held. Now this is a simplistic version. There is a path for oil to flow from here through this hole here, but it's a very slow flow. It would allow the boom to go down, but it would not allow it to fall suddenly. So let me confess something else here. Not really a confession, more a thank you. 3 people have really helped me on this repair. 2 technicians and a heavy equipment parts guy contacted me independently and said, hey, if you ever need help with anything, let me know. Well, sure enough, I've been corresponding with all 3 of them. They've all been very helpful. One in particular knows this machine like the back of his hand, and he was nice enough to give me his phone number so that I can text him with questions. We've even spoken on the phone a couple of times. So Dean, thank you very much. You've made a difficult situation a heck of a lot easier. I just had a conversation with him and he's told me how I can get this boom to go up. We're going to be doing some janky hot wire in here. Let me show you what I need to do. This is the electric hydraulic pump, also known as the auxiliary pump. And it is powered through this wire right here, which goes over to this solenoid. Looks like a starter solenoid, but it's actually a solenoid to engage that pump. This goes directly to the hot of the battery. So if I jump that pump will run. And I've got a hammer here, you know, the key. See that? That makes the pump run. Okay. So now how do I get the function to do what I want it to do? 2 valves I need to control. This is the dump valve. This defaults to sending all the pressure from the hydraulic flow back to the tank. And if you want a function to work, this valve needs to be energized, which will then send pressure to the manifolds here, the control valves, and allow functions to occur. Well, this is the lift function, this valve. I think the wire, and Dean thinks the wire that I need to hot wire is this wire, but on the other side. And it's one of these. I'm pretty sure it's this one right here. So if I put 12 volts to this wire, that is going to put this into the lift mode. If I put 12 volts to this wire, that is going to send hydraulic pressure to this manifold. So those 2 hot wired should make it lift. Then all I need to do is go to the other side and jump that solenoid like we just did, and the boom should go up under battery power. Once the boom's up, I can get under there and see what the heck's going on. Right now I can't see anything. That's about the best view I have, and there's no fitting me in there. All right, here's my setup. The dump valve I have hooked to this, and this is a jumper cable going to a battery. The ground of the battery is going right there, so I can use a second battery on this side of the machine. Here I've tied into the lift function right there, and it also is going to be hooked to positive. So to energize those, all I have to do is hook this to the positive of the battery. All right, so I'm going to go energize the 2 controls. I'm going to come over here. We're going to short that solenoid. The boom should go up. Or maybe not. So it looks like I may be on the wrong dump valve, or at least I'm not on the dump valve. So in other words, the fluid's flowing, but it's all just going back to the tank. It may be this one, so let me give that a try. Told you this was going to be janky. Hot wire and a boom lift. All right, let's try this again. That's going down. This center control valve controls the lift function. One side is up, the opposite side is down. Right now I'm hooked to the opposite side wire, so I just need to hook to this wire that my thumb's on. All right, I flipped to the other side of that control valve. Hey, we're going up. Okay, it's the next day. I'm going to finish putting this up. I just strapped the power track to the boom, and also went out there and made sure that was properly attached. I'm going to put this thing all the way up so that I have good access under there, but I don't want to put it up and then have stuff start falling. It'd be a cascade of errors. We're trying to avoid that. Alright, so this is probably stupid, but I do not feel safe getting under that thing. You just feel like you're about to get crushed. I feel safe when I'm up in it. If I'm safe 80 feet up in the air standing in it, then I should be safe standing under it, right? Yeah, I know. Whatever. I'm going to put my excavator there just as a make me feel better kind of thing. The excavator doesn't have holding valves on it, so it being up there might actually be more of a hazard to me than not. I'm good with that. Let's go take a look, see if we can see what the problem is. Okay, right down there is where the fire was. Isn't that lovely? See this wire coming up to a limit switch, but that's just a wire and insulation, so I think that's okay. This one wiggling. Yeah, that one also got beat up a little bit, but again, just a wire, as long as it has continuity and it's not shorting out. All the hydraulic hoses, this whole bundle here, looks good to me. I see one hose that concerns me. It's straight down right there, right beside the choke cable. So that hydraulic hose goes to the valve block on the main lift cylinder. Why is the ignition not coming on? Let's see any other wires. Ooh, that's just a grease hose, but that's toast. Alright, so here's the deal. I just have nothing going on here, and there's no reason anything in this box would have gone bad, except maybe there is. I had a bunch of wires all touch each other, so maybe something shorted out somewhere. So I checked the switch. That does work, but there's no power to it. When I put my meter on it, I have continuity between those two poles. This third pole doesn't even have an attachment on it. I checked these fuses. You know, they don't look blown, but maybe they blew and aren't showing me that they did. But they all have continuity. All the relays in there are for functions except this ignition on relay, and there's no power at it. So I don't think that's the problem. That would be the only thing in here. See, everything else in here is like speed cutout, governor, dump valve, start signal relay. They're just not things that would affect the ignition coming on. And there's no other wires under there that got damaged that I can see. The wires that I repaired, I am very confident in. I did one at a time, so it's impossible that I mixed any up. And I soldered every one of them. They are connected. These other wires here go underneath the oil tank and into here, and those are unaffected. So back over to the engine bay, I started tracing power. This is the, well, let me show you. This is the positive battery cable right here. It comes down, goes that way. This is it here. It goes to this solenoid, which is to energize the aux pump. And then it goes up here to the starter solenoid. And then there's a couple of taps off of that then go into this harness. Well, I've got good 12 volt power here. What I don't have is 12 volt power here, and see how that's burned? I think, and look at that. Wow, insulation's all tore off of that. So yeah, let me disconnect the battery, and oh, look at that, that's nice. I think that's my problem. No power. All right, let me fix that up. New ring connector on it. I shortened the wire, it didn't need to be that long anyway. Should be back in business. Let me hook the battery back up and we'll see. Here we go. Key on. Ignition on. I have juice. Okay. Should not be any problem to start it. Pull the choke. Yes! Oh man, I'm happy to hear that. Okay. That line is the one that really took a beating. The rubber is burnt almost all the way around. I've got to replace that. This one actually it's got grease and stuff on it. It's in good shape, thankfully. These have some grease on them, but yeah, they're all right. The only other one I see is this one. This one here has it's pretty charred too. So 2 lines that I'm going to replace. I'm not going to fool around with this. Would have been nice to be able to get out of this without having to pay, but I'm an idiot. I started a fire. I don't want to be up in the lift wondering about those lines, so I'm going to replace them. I have traced the worst line, and it comes to this point right here. Now this is the pilot for the holding valve on the main lift cylinder. If this line were to blow, the cylinder would go down. It wouldn't go down at catastrophic speeds because it's got a small hole, but it's definitely not one that I want to just randomly blow when I'm using this lift. That could be bad. I mean, you're in a tree or something, suddenly your boom starts going down and there's nothing you can do about it. Not fun. Regardless, we're going to replace these lines that got damaged. I do have the boom propped with my excavator. Let's see how this goes. Oops, wrong way. Okay, here's one side. So I just pulled that through just to verify that that's the right hose. Here's the other side. I've done this fitting before. All right, we are back in the control box area. This is the one we just did. This is the next one. Oh yeah, it's real easy too. It's like rusted into position. Man, I think that thing was cross-threaded when it was put on. Something, those threads are not right. Other end of that hose. And there you can see the damage. And it goes right here. All right, I found a third damaged hose. It went from there back through that hole and up to right there. Right there. Right. Where is it? Right there. I can't see it on this little screen, but I'll zoom in. So I've got 3 lines I need to replace. Fortunately, they're all fairly small caliber lines.
Now that's a lot of damage!
I don't think this is going to cost me a fortune, although it is 2023. It'll cost enough. So that is steel belting that's exposed there, and looks like that's already got some rust on it. Yeah, I mean, these would rust out and then blow out, and I just want to replace them now. I don't want this lift to be failing while I'm in the middle of using it. We'll see what that costs. Probably, what, 120 a line, 130, something like that. So $400. Hopefully I'm not putting up the Goodfellas laughing scene right now. I got some parts. There's the new version of my Nemesis pin. That was only 51 bucks, believe it or not. Hydraulic hose, sheave pin and bushings, and the seal kit. And speaking of parts, this is Bennett Equipment. They're in South Carolina. Now, this is not a sponsor. They didn't ask me to do this, but they've been very helpful, and it's a family-owned business, so I want to support them. They're trying to do good work and do it well, and they've treated me very well. They've found everything that I need. They've gotten it to me quickly and for the best prices I could find. So if you need parts, you need equipment, they do all sorts of stuff. Check them out. I've been dealing with Rob over at the parts department. Thanks, Rob. Appreciate it. In fact, working with Bennett Equipment, I was able to get all 3 hydraulic lines shipped to me for $180 total. So I got one of these hoses. It's the one that goes right there. I'm going to go ahead and put it in. I'm still waiting on the other 2. They came from different warehouses, different states. This one I think is going to be better to snake through from above and then pull it this way rather than trying to go the other way. So let's go up there. All right, we're up on top, and this end with the 90 goes into the control box. So let's see if we can snake it in here. There we go. All right, should be able to go pull that through. If I can reach it. There it is. Now I gotta snake the other side through one of these holes. I don't remember which one it was, actually. I don't imagine it matters. Probably that one, because it's closer. Oh, not too bad. And right through there. Okay, here's the line. And here's where it needs to go. Click! Here's the hose, and it goes right there. So, thinking about this fire, you can see that this whole area is relatively clean. I've got some leaves that have recollected here. I did clean this out. It had a whole bunch of junk in here when I got it. But I didn't get all the way back in there, because that is a very difficult area to reach. But I do have an access hole through the wall there into the engine bay. So I'm gonna clean that out as best I can now. But I'm thinking on this, that right there is the fuel line. The fire was way back there, so the fuel line was at least not an imminent risk of going up. Man, if it had just gotten through one of the hydraulic hoses and dumped oil all over it, it could have really flared up on me. Anyway, I think if this thing was still packed full like it was when I got it, that fire would have been a heck of a lot worse. So yes, keep your machines clean. Let's go have some fun scooping gunk. Can you see that? That's lovely. So that's what I got out of there. Oil-soaked leaves and twigs. That's a great place to throw some molten slag, isn't it? Yeah, I love that. So you remember that long grease hose I found down in there that got burnt up? Well, it went to this right here. There's still 2 other grease zerks there that are functional, but I didn't want to be greasing that into nothing. So I took that off, but it turns out I had a use for it. That's the pin for the slave cylinder. Basically, there's a cylinder on the other side of this wall that was greasing. With a long time and a lot of trying, I actually was able to get this grease hose screwed where that one was. And then I just put the grease zerk that was there on the end of this. So all I have to do is just remember to grease here. This is easy to get to. So this is degreaser. So that black down in there is rust. It's just surface rust. It's not a problem. So my hoses came. I got 2 more hoses to put on. Let's get it done. Okay, so I just did that one right there, and it goes to right there. So one more to do. It goes from here to up there. I try to go up and down as many times as possible. That hose up there to right here, hooked up, torqued to spec, of course, and wouldn't you know it, I'm pretty sure the fire damage is all good to go. So it won't go up. I think I know why. I think it's the wire to that limit switch. So a little more work to do. Actually, it might not be those wires. There is a horizontal limit switch that when the axles are not extended, it won't let you lift past horizontal. And I had forgotten about that. Of course, my axles aren't extended and it's above horizontal, so it won't let me lift any further. One of these charred wires we looked at earlier goes to this limit switch. The other one goes to a telescope limit switch. So now I've set the horizontal limit switch so that the lift thinks the boom is below horizontal. All right, cross your fingers. Well, there you have it, guys. I know that probably wasn't the most exciting video on this lift, but All of that had to be done. Well, the model didn't, but I hope you found that part interesting. I certainly did. So now that we got all the fire stuff out of the way, next week we're going to continue on with getting this thing fixed up and get it back together, because I got a job I need to do with it. So thanks for watching, guys. We'll see you on the next one.